And welcome to the second part of this lesson on polar coordinates. And we're going to spend this video converting rectangular equations to polar form and converting polar equations to rectangular form. The idea being equations. So what we're switching from is we were converting points like 2 pi over 4. And then we would say that x is equal to 2 cosine pi over 4. We would say that y is equal to 2 sine of pi over 4. So x is equal to 2 times root 2 over 2. Y is equal to 2 times root 2 over 2. And so the rectangular coordinate would be root 2, root 2. And this would be in a polar coordinate. That would be a rectangular coordinate. Now we are going to convert equations. It's not as easy or straightforward. So sometimes you're going to have to use a little bit of creativity because not every rectangular equation looks pretty in polar form, and not every equation in polar form looks good in rectangular. You want to be able to go from rectangular to polar and even parametric, because in the future, depending on the situation you're in, it might be easier to talk about an equation in its polar form or its parametric form versus its rectangular form. So that's been the purpose of learning these different ways of talking about equations. All right, so here are going to be your main strategies for converting rectangular equations to polar form. You want to remember that r squared is equal to x squared plus y squared. And then also we would replace an x with an r cosine theta and replace a y with the r sine theta. So let's go to our first example. Our first example is we're going to convert the rectangular equation to polar form. Well, I know that x squared plus y squared is equal to, I don't know why that's moving so weird. Okay, I know that x squared plus y squared is equal to r squared, and so that's equal to 16. And because we're dealing with distance, when I take the square root, x squared plus y squared equals 6 is equivalent to r equals 4. Why is that? Well, if I take a rectangular graph, x squared plus y squared equals 16 means I have a 0, 0 center, and it means my radius is 4. So I would go to 0, 0, and then I would go out a distance of 1, 2, 3, 4, 1, 2, 3, 4. And I know that you are all awaiting my pretty circle. You know it's probably not going to be very good. Actually, it didn't turn out awful. So that is what it is in rectangular form. All right. But then if we talk about this in polar form, okay, r equals 4, if this is my axis, would be the 1, 2, 3, 4th concentric circle. So again, there's my rectangular and there is my polar form. Here we are at example 2. Again, what we're doing is this is a rectangular equation, and we are going to convert this rectangular equation into a polar equation. So I gave you some strategies in the previous slide or previous example, all right, where we know that r squared is equal to x squared plus y squared. Well, I don't really see a lot of x and y going on, so now I'm going to go to strategy 2, where if I see an x, I can replace it with r cosine theta, and if I see a y, I can replace it with r sine theta. So I'm going to take this y and replace it with r sine of theta. Okay, if I am trying to get this into a polar equation, it's not always necessary, but usually we solve for r or we get r squared by itself. So in order to do that, I'm going to divide both sides by the sine of theta. And while 6 over sine theta works, I can rewrite that more efficiently as 6 cosecant theta. Now, why does this work? Well, if I have y equals 6 and I want to graph that in rectangular coordinates, I think that that is pretty self-explanatory. If I graph y equals 6, I would go to, let's see, this is 2, 4, 6, and I would draw a horizontal line. All right, I'm going to use some technology to graph it in polars. Okay, so here's a good picture. Okay, I'm going to go to head to menu, and I'm going to go down to graph type, and I'm going to go down to polar. And notice how I have r1 of theta, and I'm going to graph 6 cosecant theta, and theta can be found from the pi menu. And when I graph it, notice how I get the same thing in polar format. And this is the third example, and it will be not the last example of this video, but the last example of converting a rectangular equation that has x's and y's in it and we're going to convert it to polar, which will have r's and thetas in it. So if we recall our strategies, if we see an x squared plus y squared, we can replace it with r squared. I see an x and a y, but even if I try to square both sides, I'm not going to really be able to change the operation. But what I can do is use the second strategy where we're going to replace x with r cosine theta and replace y with r sine theta. So I'm going to take the 2 and I'm going to multiply it by r cosine theta times r sine theta, and that's going to equal 1. Now, if you think about this, you wouldn't have to write this on your paper, but this is just 2 times r times cosine theta times r times sine theta equals 1. And I can rearrange my terms to be 2 times r times cosine theta times sine theta equals 1, so that I would yield 2r squared cosine theta sine theta equals 1. Now, this is one of those situations, and I even talked to Mr. Townsend about this, that you'll see I'm going to leave my answer. You can leave it in terms of r equals or r squared equals. So to isolate the r squared, I'm going to divide both sides by 2 cosine theta sine theta. So r squared is equal to 1/2. The reciprocal of cosine is secant, and the reciprocal of sine is cosecant. Okay, so this would be my final algebraic answer. And the following is not necessary. I am just showing you on the calculator to show you how these are equivalent. That 2xy equals 1 as a rectangular equation is equivalent to r squared equals 1/2 secant theta cosecant theta. So if I, and hopefully, yep, it's good, not a bad glare. So if I have 2xy equals 1 and I want to solve for y, I would have to divide both sides by 2x. So I would have to take 1 divided by 2x. And that is the graph that I would get. I would get this rational function. Okay, now, if you notice r squared, if I would want to solve for r is equal to plus or minus the square root of 1/2 secant theta cosecant theta. So you can plot those on the graph in polar form. So I'm going to keep this same window. I'm not going to open up a new one. But what I am going to do is, instead of graphing it in function form, I'm going to go ahead and change my graph type to polar. Okay, and what I'm going to do for the polar is I'm going to type in the positive square root of 0.5, which is a little bit easier to type in than 1/2. And then I'm going to type in the secant of theta times the cosecant of theta. And notice how I get part of the graph. You see the graph kind of overlapping a little bit on the red, but it doesn't completely overlap the red. That's because I still have to graph the negative part. I have to graph the negative square root of 0.5 times the secant of theta times the cosecant of theta. And when you put those both together, does it make sense that now the blue is on top of the piece that it wasn't highlighted before? And 2xy equals 1 is equivalent to r squared equals 1/2 secant theta cosecant theta in polar form. All right, so the remainder of this video is going to be devoted to converting polar equations to rectangular form. So that means taking equations that have r's and thetas in them and converting them to x's and y's. I found this quote really interesting because I highly related to this after I had done these problems. Converting a polar equation to rectangular form requires considerable ingenuity, meaning I can't give you recipe math. I can't give you a strategy. There are some beginner ideas that should be intuitive, but some of the examples that I'm going to show you today really just require some ingenuity, and not every single rectangular form is necessarily going to be in y equals. You're going to maybe have x's and y's all over the place, and sometimes they can be messy, which honestly is not a bad thing. It's just if you're trying to make them not messy, you might spend too much time on one particular problem. So make sure you're asking in class if you're on the right track as you do these problems. So let's look at some simple problems to start off with. R equals 3. If we look at this in terms of its polar representation, if this is my axis, I would just highlight the third concentric circle. Well, remember we had talked about that r squared is equal to x squared plus y squared. So if I square both sides, r squared is equal to 9, and then I can substitute in x squared plus y squared for r squared equals 9, and now I have converted the polar equation r equals 3 back to rectangular. So from a rectangular perspective, okay, if I would graph x squared plus y squared, let me make this up a little bit higher, plus y squared equals 9, well, this means I have a circle with center at 0, 0, and then a radius of 3, just like I had on my polar paper. So that's how they convert. Okay, putting those, let's put those side by side so you can see them. Okay? All right. They're not necessarily the same scale, but you get the idea that you get a circle with a radius of 3. All right, now let's talk about theta equals pi over 4. So from a polar perspective, let me fold this paper so I'm only showing one polar graph. Okay, here's what happens. Okay, well, pi over 4 converts to 3 pi over 12. So I'm going to go 1, 2, 3. This is where pi over 4 is. And if I highlight that particular pole or that particular axis, what you end up with is a straight line. So how do we convert this to rectangular form? Well, a way that we can think about this is if theta is equal to pi over 4, let's think about it in terms of its tangent. The tangent of pi over 4 is equal to root 2 over 2 over root 2 over 2, which is equal to 1 over 1. Isn't that equal to the y-coordinate over the x-coordinate? So my y is equal to 1, my x is equal to 1. So when I put this in rectangular form, doesn't y equals x? And if you think about this from a polar perspective, isn't that a perfect 45-degree line? And then from a rectangular perspective, I would have a y-intercept at 0, 0, and my slope would be up 1 over 1, up 1 over 1, up 1 over 1. So that's why those two would also be equivalent. So that the polar equation, theta equals pi over 4, is equivalent to the rectangular equation y equals x. Here we are at example 4, where you are given an equation in polar form, and I know that because I see an r and I see a theta, and we need to convert this into x's and y's. So here are the things I know. I know that r squared is equal to x squared plus y squared, and I know that x is equal to r cosine theta, and I know that y is equal to r sine theta. So those are kind of my strategies to work with, and now I need to use that ingenuity to figure out what's going on. Well, if this was an r squared, couldn't I substitute x squared plus y squared in for that? And also, this doesn't, I've got a 2 cosine theta. If I had an r cosine theta, I could substitute in an x for that. So what I'm allowed to do is whatever I do to one side of an equation, I do the other. So I'm going to multiply both sides by r. When I do that, I get r squared is equal to 2r cosine theta. Again, 2 cosine theta and r are all being multiplied, and so there, I use the commutative property to write the r here. Well, I can substitute for r squared, I can substitute x squared plus y squared. And for the r cosine theta, I can substitute in an x. So you can leave that as your final answer, or you can leave it as x squared plus y squared minus 2x equals 0. For the sake of time on the video, I'm not going to get out the graphing calculator and show you that they're true, but if you would solve for y, and so you would have to take the square root plus or minus the square root of x squared minus 2x, if you would graph those pieces, and then if you would go to polar form and graph r equals to cosine theta, you would get the same graph. Here we are at example 5, r squared equals sine 2 theta. Again, the clues that tell me this isn't polar is because I see r's and thetas, and we need to convert this to something that only has x and y's in it so that it is a rectangular graph. So again, some things that I know are that r squared is equal to x squared plus y squared, and I know I can substitute r cosine theta in for x, and I can substitute in r sine theta for y. So I'm looking at this and I'm saying to myself, you could go ahead and put in x squared plus y squared for r squared. That's a step in the right direction. But I don't know what to do here. I have the sine of 2 theta. Oh, that's a double angle. things that make you go, You've got a double angle formula. So again, this wasn't one of the formulas I had you memorize, so you can look at your notes, you can look at the book, but you need to be able to find the sine of 2 theta, and we know that that's equivalent to 2 sine theta cosine theta. So you're like, great, Nop. I know that I can substitute in x for r cosine theta, but I just have a cosine theta. I don't have an r there. And if I would multiply both sides by an r, well, let's think about this for just a minute. I could multiply both sides by r and then multiply by r again. Again, I'm using that ingenuity a little bit because this would yield r squared, x squared plus y squared. And then isn't this 2 sine of theta cosine theta times r? Well, remember multiplication is commutative. So I could rewrite this as 2 r sine theta, r cosine theta. And voila! I can write the 2. R sine theta is y. R cosine theta is x. R squared is another x squared plus y squared. And so this is where you could keep going on and on and on and on when you don't need to. I could firm this up by saying x squared plus y squared, the quantity squared. Let me rewrite that. That wasn't clear. X squared plus y squared, the quantity squared, equals 2xy. And I know we haven't solved for y. This would be a pretty brutal problem to solve for y. From a calculus perspective, you don't always have to have y by itself. This is just a precursor. You don't have to memorize this, but this is what is called implicit form. It's implicit form because it is not in y equals form. That's considered explicit form. So it is okay to leave your answer as x squared plus y squared squared equals 2xy. And that is equivalent to the polar form r squared equals sine 2 theta. We did it. We made it to example 6. We finished the video. We're almost ready for the WPE, and we're almost ready to celebrate Thanksgiving with your families. I can smell the turkey and taste the pumpkin pie. All right, here we go. This is a little bit more complex, and I might write out more steps than you need, but again, remember that this is polar form. I know that because I'm given an equation in terms of r's and thetas. We need to convert this to rectangular, which means I only have x's and y's. And remember, it's that ingenuity. If you notice, I can still use that information that I know that r squared is equal to x squared plus y squared, and I know that x is equal to r cosine theta, and I know that y is equal to r sine theta. I keep that in the back of my mind, and sometimes I have to figure out how I'm going to get those things. All right, here we go. So notice I see r is equal to 3 cosine. It's that 2 theta. It's a double angle. So there are numerous ways that you could do this, but I'm going to go ahead and use, there's 3 different formulas that you can use for the cosine, the double angle of a cosine, and I'm just going to use good old-fashioned cosine squared of theta minus sine squared of theta. All right, so here's what I'm thinking. I'm thinking to myself, if I make this an r squared, I can substitute in an x squared plus y squared. So I'm going to go ahead and I'm going to multiply both sides by r. So I get r squared is equal to 3r cosine squared theta minus sine squared theta. And I can go ahead and substitute in x squared plus y squared. But here's my problem, friends. I still have thetas over here, and I still have r's over here. So I am not done. Well, see if the following makes sense. I can think of this as, can't you think of this as cosine theta times cosine theta? And I can think of that as sine theta, sine theta. Do not get nervous. I'm not going to cosine, cosine, sine, sine. We're not going that direction. But if I were to distribute the 3r, okay, if I were to distribute the 3r, I would have x squared plus y squared equals 3r cosine theta minus 3r sine theta. Well, there is an r cosine theta and there is an r sine theta. Life is good. I can take x squared plus y squared. This would be considered 3x cosine theta minus 3y sine theta. but I still have a theta that I have to get rid of. Well, don't you have to have a radius in front of there in order to eliminate that cosine theta and that sine theta? So what I'm going to do again is multiply by r. Okay, so I have r x squared plus y squared equals 3xr cosine theta minus 3yr sine theta. Oh, I don't need that parentheses there. Ignore that. So now I have r x squared plus y squared equals, well, again, I can think of that as an x. So I now have 3x squared. I can think of this as another y. So now, oh, I dropped my operation. I'm sorry about that copy error. Now I have minus 3y squared. And you might be wondering, okay, what in the heck do I do now? A little bit of a trick. Isn't r the square root of r squared? So can't I think of this as the square root of x squared plus y squared times x squared plus y squared? Alternatively, can't I think of this as x squared plus y squared to the 1/2? So my final answer, if I take 1/2 plus 1, is x squared plus y squared to the 3/2 power equals 3x squared minus 3y squared. An alternative way is if I would square both sides. Actually, before I square both sides, if I have x squared plus y squared to the 3/2 and I factor out a 3 over here, okay, if I square both sides, okay, this would have been a final answer for full credit. But then if I take 3/2 to the second power, a power to a power is multiplied, I could rewrite this as x squared plus y squared to the third power equals 9 times x squared minus y squared squared. So either that version or that version, they're both equivalent. So you are ready to finish this assignment. So please work on page 680, numbers 39 to 79, the odds, and 82. Good luck.